Coaxial hyperplanes. Abstract: for Euclidean geometry, the basis vectors are the source of inspiration for mutually perpendicular/orthogonal concepts that rules over the world in the form of tangent, normal, and binormal or the rectangular coordinate system. So, the Pythagoras theorem is valid in 3 dimensions. But when the fourth and higher dimensional space does not obey Pythagoras and thus the higher ideas like norm, ortho, normal basis and more are required. So, the plane in a Euclidean geometry becomes a hyperplane in the n-dimensional space for n3. Pivoting in the linear programming or the construction of ortho-normal basis using Gram Schmidts process and the PTH norm are some of the methods that scales to the required heights. In the astronomical discussions, the planets in the solar system will come as close as possible and the distance required to go round and reach back is an idea or the thought source in which the shortest distance between two hyperplanes is presented. 1 Introduction: hyperplane. In an n-dimensional linear space, how many hyperplanes would be there? Of n-1-dimensional, those form a family of symmetric subspaces. Introduction: planes through origin only will be subspaces. But the collection of parallel planes cannot form the collection of subspaces while one and only one plane will have the origin on it. For instance, 1.1, 112,211, nagxaxax equals will be a hyperplane in n-dimensional space for C is any constant and wenk equals 0, nvf. The set of vectors that satisfy the condition, 1.1, will form the subspace showing whenever C0. In the case of C equals 0, if, then will be the basis of the subspace which is a hyperplane through the origin. 12, nxxx are the hyperplanes that contain the axis as the axis of intersection or common axis or the axis of rotation for different non-zero values of and 1.3, 9. K. 1/11 NNNJJ equals. Definition: a family of hyperplanes through a common line in is a coaxial family of hyperplanes. 1.4, NVF. There are infinitely many coaxial families of hyperplanes through origin. A class of coaxial families will have coordinate axes as the axes of symmetry and other families will have lines through origin as axes of symmetry. Definition: a non-homogeneous coaxial family of hyperplanes are the family that have the line of symmetry not through the origin. 1.5. There will be a unique plane through origin in the family of non-homogeneous coaxial family of hyperplanes. 1.6. The axis can be represented by 1.7, 9. 2 line of intersection of hyperplanes. 2 hyperplanes and 1122, 0 RNNXXX, equals equals. Are clearly having the common line and so are not coincident if and only if, 2.1, 1122, 0 SNNXXX, equals equals. 9. KM. For at least one distinct pair K, M among 1, 2, I, 1, I plus 1, n. Any line not coincident with any coordinate axis will be of the axis of rotation for the family of the hyperplanes. If a line is not through origin in, then it can be parameterized as NVF. 2 lines defined by n defined by 1. 2. Definition: if n are the lines on 2 different members of a family of hyperplanes that do not intersect, then they are skew hyperlines on hyperplanes. 2.4, 1. 2. Theorem: 2 skew hyperlines in different coaxial families will be on a unique pair of parallel hyperplanes and so, the distance between the planes will be the shortest distance between the lines. 2.5. Proof: there is a unique position in which the line is in the plane 1. Since n are the skew hyperlines, at one instance, these lines will be as close as possible and the next moment, the distance between them will be more and keep increasing between any 2 points, each is on either the lines 1, 2. In other words, there is a unique pair of points and such that will be the shortest distance between the given lines. 11p, 22p, 21 npp. It can be followed that the line of minimum distance between and is such that is normal to both and 1, 2, 3 12 pp equals 3, 1, 2. So, the line is through the feet of the normal that are the points of intersection of the lines, namely and 3, 11p, 21p. Incidentally, and where is in one co-axial system and is in the other co-axial system such that will be parallel. 11, 22, 1, 2, 12 and the distance between the feet of the normal skew hyperline is the distance between the parallel planes and 1, 2. The minimum distance possible between the planes, the length of the skew hyperline of shortest distance is 2.6, 12 and 1/1, jjj sin equals dash. Note, if both co-axial systems are not through origin, then the shortest distance between the skew hyperlines, 2.7, 121/1 NN JJJDD equals dash dash. References. 1 Charles W. Curtis, 1968, Linear Algebra, page 62, Allen and Bacon, Boston. 2 Victor V. Persalov and V. M. Tikhomarov, 1997, 2001, Geometry, page 22, Volume 200 in Transactions of Mathematical Monographs, American Mathematical Society. 3 Heinrich Guggenheimer, 1977, Applicable Geometry, page 7, Krieger, Huntington ISBN 0-88275-368-1. 4 Berger, Marcel, 1987, Geometry 1, Berlin, Springer, ISBN 3-540, 11658-3. 5 Brannan, David A., Esplin, Matthew F., Gray, Jeremy J., 1999, Geometry, Cambridge University Press, ISBN 978-0-521-44177-3.